We have a population of quantitative data, which are exam scores. We are given the shape of the data as a normal distribution. The center of this data, which is the population mean, is 74 points. The spread, the population standard deviation, is 8.7 points. When given these three things, what's the first thing we should do? Draw a sketch. So here you have a normal shape. So let's put in that normal distribution. The center is 74, so put 74 in there. Now, this is a nice way to do it on your calculator. Might seem funny at first. First, I'm going to enter in whatever the mean is. In this case, 74. And I'm going to subtract 1. I know that seems funny, but you'll see why I'm doing it that way in a minute. And put in whatever the standard deviation is in parentheses. Hit enter. Now press the second key and the enter key, and you get the last thing you just entered in. Then just go over there and change that subtract to a plus and hit enter. So the middle 68% of all these exam scores are between 65.3 and 82.7. Let's get that in our sketch. Now press the second key and the enter key, and let's just change this +1 to a subtract 2. Press the second key and the enter key and change that subtraction to addition. Now we know the middle 95% of all these exam scores are between 56.6 and 91.4. Get that? Put on your sketch. And let's go ahead and calculate 3 standard deviations below the mean and 3 standard deviations above the mean. So 99.7% of these exam scores are going to be between 47.9 and 100.1. There. Now what you have is a very nice summary of the entire population. And in this video, you'll see why I strongly encourage you always to start with this. Make the sketch, because it's going to help you in a number of different ways to master this material. We've been given the shape, center, and spread. It's all that needs to be said. And now we could find the probability of one randomly selected exam from this population being between 61 and 78 points. And you know the first thing I'm going to do, I'm making a sketch. All right, let's find 61 on here. Where would that be? Oh, it's right here. Hey, how did I know that? I just took that 61, turned it into a z-score. Easy enough to do. So here we go. I'm just going to do a little left parenthesis, put in 61. And first thing, how far does 61 deviate from the center? Well, that's what subtraction tells us. How many times will the standard deviation fit into there? Well, that's what division tells us. So let's divide the standard deviation into there. And this is how I knew that 61 is about 1.5 standard deviations below the mean. So that made it quite easy to approximately locate where it was. And let's do the same thing for the upper bound. See, the upper bound is 78. Now, how did I know it was right there? Well, I knew it was between 74 and 82.7, but how did I know it was right where I pointed at? Well, as you would guess, I used the old z-score. If I took 78 and I subtract the center of 74, divide by the standard deviation 8.7, see how many times that fits in there? Oh, so it's about just under 1/2 of a standard deviation above the mean. So that's how I knew the upper bound was there. And so we are between that lower bound and that upper bound. So shade in the region in between. All right, with that shaded in. Where's our x? Well, it's in between these two, so let's put it in between. All right, now that you got in between there, now here's the secret. Only compare two things at one time. So let's just compare the 61 and the x with each other. All I got to know is who's bigger, who's smaller. Well, that's easy. These are placed on the number line. Whoever's farther to the right is where bigger numbers are. X is to the right, so it's the biggest. So x is greater than 61. Now let's just compare x and 78 with each other. Who's bigger, who's smaller? 78's farther to the right, so 78 is greater than x. All right, now let's just put parentheses around that. Slap a capital P in front, and there you have it. There is your nifty shorthand notation, the probability inequality notation, the nice short way of writing the sentence we have up here. Rather than write all those words, I just got this notation right here. Well, that definitely is a lot shorter, isn't it? For lower bound or upper bound, this is a job for normal CDF. And it just needs to know the lower bound. The second value is the upper bound. The third value is the center. The final value is the spread. We have all those. So let's just go ahead and enter that into our calculator. So we press the second key. Then we press VARS. Then 2 to select normal CDF. Put in our lower bound is 61. Our upper bound is 78. And our center of 74, comma, and our spread of 8.7. Now, you've got to put these numbers in the correct order. If you don't, you're not going to get the right answer. Well, notice how our sketch made it real clear what the lower bound, upper bound was. Hit enter, and there's our answer. Now, I'm going to let you know a little secret about statistics, particularly this topic here. You got your answer. Don't think that you're done now. You're not. Now, it's true. In a typical math class, you're usually done. Hey, I got my answer. Now I'm going to move on to the next one. But in learning statistics, especially the concepts we're learning here, the real magic, the real important part of the assignment is what you do once you get that answer. This is where you're going to really master the material. You probably don't realize it, but you are learning some valuable concepts that are going to allow you to understand inferential statistics later on. I just want you to know this is a pretty key important assignment. In fact, the next few are definitely that way. So, what am I supposed to do now? You're going to state that answer as a probability and as a proportion. And it's key important that you do that on every one you do. And you don't necessarily have to write it out every time, but you should always say it in your head, the two interpretations. Because you know that's actually the main point of you doing this assignment, is to get that reinforced. And having your sketch to look at helps. It helps tremendously because you can visualize the answer. This answer has great meaning to you. You really know what it means, but only if you practice interpreting it every time you get it. All right, our two interpretations for our answer. First, let's state it as a probability. There's a 60.96% probability that one randomly selected exam from this population will be between 61 and 78 points. Now let's ask ourselves, is this an unusual event? No, because the probability is big. It's way more than 5%. Now, stated as a proportion. 60.96% of all these exam scores will be between 61 and 78 points. Okay, and here's another thing that would be helpful for you to reflect upon. The big picture says, look, they gave me the interval. You notice those numbers are always inside the parentheses here. 61 and 78 are points on the number line. And I was able to find this area under the curve using normal CDF. Normal CDF gives me an area under the curve, and the area under the curve is a probability and it's a proportion. Now, what's really important is these numbers, that you don't get them confused with each other. Some numbers are areas under the curve, and other numbers are points on the number line, or quantitative measurements. So always be crystal clear on that, because it's going to be very important to you later on. Because if you're not crystal clear on that future assignment, you're going to be really confused. So it's important to reflect. And also reinforcement normal CDF does. Yeah, it takes the interval and gives me the area. All right, now you can move on to the next one.